Hello, let's continue with the previous tutorial. We were talking about Onshape, how to do geometry for our CFD workflow, but I want to mention a few things that I didn't say in the previous tutorial. So remember, I made this tutorial, this geometry public, so you can come here in public cases and probably you can look for Ahmed body, and then you will find it here, or you can look for OpenFOAM. Probably there are a few tutorials, I don't know. So yeah, so let's go to this one, Ahmed body, the one that we were doing, and I hope you save it. If not, you can get it from Onshape. So basically, this is the geometry we have, okay, and starting from this geometry, in our next tutorial we're going to do the mesh. But something that people complain a lot says that the measure that comes with OpenFOAM, which is the solver that we're going to use, there is no GUI. The meshing process is kind of very visual, it's very tricky. So I'm going to show you that while that is true, that there is no GUI and the meshing is very visual, you can rely on some other tools to get those visual reference. So here I'm going to use Onshape to get an idea of my domain and then export some external geometries. I'll also get coordinates to do my meshing in black mesh. So I already did here something that also I just want to mention as well, that I didn't say, I didn't press. Probably if you have used it, you will realize that there is no save function. Okay, everything is automatically saved in Onshape, and also everything you do is saved here in the history. And as you see here, I already have some branch. So this is my original project. Then here I create this version 1. Version 1 is frozen, I cannot modify. And from this one, I create this branch, okay? So also this can be really helpful. You can create several branches and people can work in different branches and workspaces. And the history is here. So if you want to go back, okay, to previous moment, I know, a previous operation, you can access everything. So basically everything you do can be accessed here. So I will go to branch 1 and I will show you that I already have my domain, how I want to look like. So it's saving everything, takes a while, and this is my domain. So I have my body and I would like to have a dimension like this, okay, something like that. Remember I told you also something that using variables, parametrize things can be really helpful. So look here that I already created a few variables to define my domain, the external box. So for instance, what I did was I create first this sketch. No, it's not that one. Okay, no, that is the okay, will be this one. So this is the button sketch, and see that I added these dimensions. Everything is parametrized. So basically here you will see that I have this variable here, box, times this value. Okay, so for instance, if I want my domain to be, let's say, bigger, I can put here 10, and then I can get an idea how it will look like. Also, you can get an idea how many cells you can get. Okay, so always the question, how big is my domain? Sometimes you work in external dynamics, aeronautical applications. Usually you need big domains, something like probably 15 to here, and then the front also about 8. Okay, and well, your domain will look like something like this. It's kind of a big one. Also, you need to put it to the side, so it will be also like 8. Well, I will leave this one. This is a, let's say, low Reynolds number, and we can use small domain, and probably I want also to reproduce the conditions, when done or whatever. So I have my external domain, and also see the internal one, that this here I will apply a refinement sign. Okay, so I can save that STL. So remember, you can save your STLs here. You select the part and then right click and export. Something really important, when you export, just do not use spaces. Remember that Linux doesn't like spaces, so use put something like my body, something like that, but do not use the spaces. So be careful, because if not, when you work in Linux, it will complain. Then I have this one, the external and the internal there. For instance, you want to change the appearance, you right click and you see in the appearance, you can change the color and also the transparency. And I want to say as well that, for instance, if I want to get the coordinates of the external box and then you use those coordinates in black mesh, for instance, you click here and see here that you have the coordinate here, okay? So see that always in the right corner. Well, here I have this hell. Let me see how I can get rid of this. Okay, I don't know. Okay, I don't know how to get rid of that. But in any case, so I click here. You get here your coordinates again. You deselect, you create, so you can just copy your coordinates, and then when you go to black mesh, you just insert those values. Something really helpful also that you can measure distance. So select this one here, and then you have the minimum distance, but also you can select how it changes in delta x, delta y, and delta z. I don't know. Okay, so it's really, really helpful. So always look to this right corner, see here your minimum distance. You get a lot of information. If you click in this surface, you get here the area. Well, you don't see anything. We have the helm there. I don't know how to get rid of that. Okay, so that was something that I wanted to tell you about Onshape that I didn't mention last time. So just play around with these actions. It's really easy to use if you already have used something else, SolidWorks, you will find that is very similar. So now that I export my geometry, again, I have it here already open in Paraview. So again, people say, okay, I have my whole STL, but I would like to separate my STL in different phases, and that also can be done. Okay. So there are many tools, but we can use Paraview to do that as well. So I will show you how to, for instance, I want to select this face here and have a separate face. And probably when I do my meshing, I will have here a different refinement. And also I can select that edge, this edge here, and again, I can apply a refinement just for this edge. So as you see, we have complete control over our geometry, like in commercial software. Okay, but in commercial software you have the visual interface, the GUI that you just click in the screen here. It's a little bit tedious, you need to do many operations, but for instance here in Paraview I'm using this one because you can use Python scripting and do many things automatically and all this operation automatically. So let me show you how to, for instance, I want to select this face. We go something like this. So you have the triangles here. And look at here that you have these options here, these operations, and I want to select this one, interactive cells. Okay, you come here, select this one, and see that you select those two faces and what you can do now. And for instance, let me select also this face here. Okay, so I want to extract this surface and then apply a refinement different from the rest of the body there. So you come here, extract selection, and voila. There you have the second surface. You extract it from the original one, and then you can export this surface to STL format. Something that before exporting to STL, you will need to convert to extract that surface. Okay, so you apply that filter, and now you just come here, says data, and you have STL here. You save STL, and then you have your other geometry that you can apply a different refinement. So let's say, for instance, now still working in this STL, I would like to apply also a refinement here in this line, or even you can draw a line, add a line in this surface. It's a little bit more tricky, but it can be done without a problem. So let's extract this line from this surface. So here also there is another filter called filter edges. And you see here those blue lines, those are the edges that we extracted. Okay, now those white lines. So I hide this one. So I would like to extract this line here, okay, and then apply a refinement there. So for instance, again, you can come here, you have this option. So select cells, something like this. You select that cell, you extract it again. Okay, and now you see that you have this single line, and then again you save here. Now be careful, because in lines in OpenFOAM or Snappy XMesh, you need to save it as VTK format. So you save that line as VTK format, then there is another utility in OpenFOAM I will show you later how to convert it to the format that OpenFOAM will recognize that will need to apply different refinement there. So as you see, contrary to what you think, you have a lot of control. Okay, since can be a little bit tedious, but you have all those visual reference here, so you can rely on Onshape, create your domain or those boxes, get coordinate for block mesh, and then come to Paraview. And Paraview, you want to extract surfaces, extract those surfaces, and then the rest is Snappy XMesh that will be our next tutorial. And the next tutorial just going to show you what we're going to do. We're going to generate just the mesh that I think I already have here. So look at that. It's a beautiful mesh, our domain. Okay, you see that we have a refinement sun, and let's zoom in here. Okay, and see that we have a beautiful boundary layer mesh there. So I'm going to show you how to generate that boundary layer mesh and some tricks, because usually people also complain that, oh, my boundary layer is always collapsing. Here I have a 100% coverage of the boundary layer. So as you see here, let me show you something that is very uniform. It's always not collapsing here. Usually when you have those sharp angles, the boundary layer collapses. So we're going to work in this. This, contrary to what you think, is really easy, really fast. So you just need to identify what are the changes that you need to do in that dictionary, and that's all. You are done. So thank you very much, and see you next time for the mesh tutorial. Bye.